Hi, this is Kori Pekarek, and today we are going to talk about a specific finite geometry. In this geometry, there are three axioms, and they are A1, there exist exactly 4 lines. A2, any 2 distinct lines have exactly 1 point on both of them. And A3, each point is on exactly 2 lines. And in this video, I'm going to prove why this geometry has exactly 6 points and why each line in this geometry has exactly 3 points on it. So, I'm going to go about this not by drawing a picture, but simply by using the axioms to prove these 2 points. So, when we look at these 3 axioms, we know that each line has to share exactly 1 point with every other line, and at each of the points there's exactly 2 lines. There can never be 3 or 4 meeting at the same point. So if we just label our lines line 1, line 2, line 3, and line 4, we know that lines at 1 point, lines 1 and 2 have to meet. At 1 point, lines 1 and 3 have to meet, and at 1 point, lines 1 and 4 have to meet. So line 1 has to meet each of these 3 points once at separate points. And then we're going to go on to line 2 and see where line 2 is going to have points. So line 2 has to meet line 1, but we already have that point listed right here. And then line 2 also has to meet line 3, so I'll write that down. And then line 2 also has to meet line 4, so I'll write that down. Now we'll go on to line 3. We've already listed line 3 meeting line 1 right here, and then line 2 meeting line 3 right here. And then line 3 also has to meet line 4, so that will be a separate point. Moving on to line 4, we've already listed points here, here, and here, where line 4 is going to meet lines 1, 2, and 3. So right here we have 6 points listed in this box, and these are the only 6 points that can exist in the geometry because we have listed where each line meets each other line 1 time. There are no repeats, and we have listed the 2 lines that meet at each point, which makes sure that A3 is always correct because each line has exactly 2 points. There are never more than 1 at a point. And so now I'll explain why each line has exactly 3 points on it. So if we picture a line on the geometry, we know that the line, based on A2, we know that the line has to meet each point at least once. And because of A3, we know that each point only has 2 lines on it. So if we say this is line 1 right here, we'll have this be line 2, and so this is line 2, so there's this point where it meets line 2, and then we'll have this point be line 3, so this is where line 1 meets line 3, and then this is line 4, so this is where line 1 meets line 4. So this line has 3 dots on it, and we can't have any, or it has 3 points on it, and we can't have any less than 3 points because then there would be a line that doesn't cross line 1, and that would make A2 not true. And we can't have any, in another geometry, say, we could possibly have line 3 like going through like this, where it went through the same point as line 2, but because of A3, we can't have that happening. That doesn't work because each point only has 2 lines on it. So because of A2 and A3, we know that there are going to be exactly 3 points on each line. Thanks for listening.